Hello students, today we are going to deal with a interesting topic of chemistry, that is electrochemistry. So, what do you mean by electrochemistry? As the name itself suggests, yes, suggests there is electricity and chemistry both involved. What do you mean by electricity? Flow of electrons. And chemistry is the study of chemicals or the reactions that involves in the chemicals. For example, how does this fan work? Yes, it works with conversion of the electrical energy into mechanical energy, right? Where the electrical energy helps the fan to rotate and converts it into a mechanical energy. Similarly, in case of electrochemistry, we are going to study the interconversion of electrical energy into chemical energy and chemical energy into electrical energy. With this interconversions, we also going to study the behavior of the electrolytes. And what are these electrolytes? We will study later on. Okay. So this is electrochemistry. This electrochemistry, you must know two substances, that is conductors and insulators. Yes, what are conductors and what are insulators? Conductors are the substances which conducts electricity, where there is flow of electrons which helps in passage of electricity. So, for examples of conductors, all the electrical appliances which conduct electricity, which involves the flow of electrons, are known as conductors. And these insulators are the substances which do not conduct electricity, where there is no flow of electrons or there is no current passage. Some example for the conductors, you can give lead, all the metals, all that involves the flow of electrons are known as conductors. For insulators, there are examples such as rubber, bakelite, plastics, etc. Okay. Coming back to the conductors, conductors are two types. That is metallic conductors, that is where metals are involved, and electrolytic conductors, where the electrochemicals are involved or the reactions are involved. What are these metallic conductors? Here, the substance undergo flow of electrons or the conduction is conducted where the substance originality will not be changed. The physical property will be in their original state. For example, copper, gold, silver. These metals, when you supply electricity, there is no change of their physical property, but they conduct electricity. And coming to the electrolytes, these are the substances which conduct electricity in their molten state or in their aqueous state. And this behavioral study is mostly important in your electrochemistry branch. Here, these electrolytes conduct electricity or the flow of electron takes place only when the substances is in its molten state or in the aqueous states. For example, all the acids, bases and salt solutions involve conduction of electricity. Okay, so when you consider these electrolytes, there are two types of electrolytes. One is strong electrolytes and weak electrolytes. As the name itself indicates, strong electrolytes are the electrolytes which conduct electricity when they undergo complete dissociation or ionization. What do you mean by ionization? It is breaking up of molecules into ions. When a molecule breaks up into respective ions, it is known as dissociation. This dissociation is undergoing completely. When they complete ionize, they become a very strong electrolyte and the current passed is 100%. And coming to the weak electrolytes, these are the substances which undergo partial ionization. That is, they do not undergo complete ionization or dissociation. The ions will remain as it is in the undissociated form. They are known as partial weak electrolytes. One example, strong electrolytes, you can state all the strong acids, strong bases and salt solution. For example, HCl, NaCl, all the salt solutions. Coming to the weak electrolytes, examples are all the weak acids, weak bases like ammonium chloride, ammonium chloride for example. All these are which undergo partial dissociation are known as weak electrolytes. Okay, and here these electrolytes, when coming to the conduction, which do not conduct electricity, they are known as non-electrolytes as well. That is, they conduct electricity but they not in state of molten state. They do not conduct electricity at all. they are known as non-electrolytes. And example for this are sugar solutions, urea, etc. Though they are in their molten state or liquid state, they do not conduct electricity, and these are known as non-electrolyte solutions. Okay, so next, coming to the main part or the next topic of your electrochemistry are the electrochemical cells. These electrochemical cells are the substances which helps us to carry out the electrochemical conduction of the electrolytes in conduction of the electrons in their solution state. What are these electrolytic cells? Everybody must have seen the cell in the battery or in the remote of your TV remote. What happens there? The cell helps us to operate the battery, operate the remote using the help of the battery. And this battery is nothing but the example of your electrochemical cell. Okay, so what are these electrochemical cells? These are the devices where chemical reactions occur involving your conversion of electrical energy. And what are the chemical energy involved in here is the basic chemical energy, that is reactions, that is redox reaction. What are these redox reactions? That is nothing but the reaction where simultaneous oxidation and reduction is carried out. So, when in a reaction, oxidation as well as reduction is carrying out simultaneously, then we call it as a redox reaction. In this electrochemical cells, this is the major chemical reactions where reduction as well as oxidation will be carried out to convert the chemical energy into your electrical energy. For example, as I told you, the battery is used in your remotes and